Hello and welcome to this module called Delivering High Quality Tier 1 Instruction. My name is Terry Marks and I work at the American Institutes for Research. I'm also the project director of the Rhode Island Intensive Math Intervention Project. The content for this presentation was developed in collaboration with Dr. Mary Little, a professor at the University of Central Florida, and Dr. Brad Witzel, a professor at Winthrop University in South Carolina. As we begin this module, let's review the goals as an advanced organizer for our learning outcomes. Initially, we will review the features of high-quality Tier 1 or core instruction, including the pedagogical concepts of differentiation and scaffolding. Defining characteristics of each of these concepts, as well as examples of their use by math teachers, will be applied to a case study student, Jackson, as well. Current research supports the philosophical belief that all students can learn. Our knowledge and skills to deliver effective instruction in mathematics does make the difference. Through tireless efforts of learning and implementing evidence-based practices, the performance gap between students can be reduced. In addition, students can develop critical skills like abstract reasoning and problem solving to ensure the mastery of standards in mathematics for graduation and life skills. These concepts apply to struggling learners in mathematics, including students with disabilities, as well as English learners. It is our common goal then to focus on core Tier 1 instruction that produces improved student learning. As Nancy Zimfera stated, we make no apologies for setting high standards for all students. We as teachers and educators must know and focus the content standards in mathematics and develop and use evidence-based instructional practices and strategies while we differentiate that instruction to meet our students' needs. Our goal is to have all students achieve rigorous standards. At Tier 1, we should be implementing evidence-based practices that demonstrate improved outcomes for students. We will determine if our Tier 1 instruction is effective if at least 80% of all students, including students with disabilities and English learners, are meeting grade level benchmarks at Tier 1 or core instruction. In order to do this, we need to set clear goals. We need to identify what exactly do we expect all students to learn? How will we teach our students to maximize learning? How will we know if students learned it? Then, how will we respond when some students don't learn through differentiated instruction and/or scaffolded instruction? These concepts of what, how, if, and then will be followed throughout this presentation. Effective Tier 1 instruction involves a concerted connection between what is being taught, how it is being taught, and continuous adjustments based on data. The what is the focus on standards-based curriculum, but considerations must also be made on assessment, such as things like group level deficits. How is the focus on instructional approaches, thinking about evidence-based practices, as well as the implementation of the math practice standards, which we'll talk about a little bit more in depth and is also covered in an earlier module. And lastly, we need to think about the if-then. That is the use of assessment. Monitoring student progress provides insights into what content should be retaught or emphasized, as well as what instructional practices have been the most beneficial to students. Our goal is for all students to achieve rigorous content standards. At the core instructional level, we need to address the standards and understand the progression of those standards over time. The features of core instruction modules discuss these progressions more in depth, and they are displayed on the screen. We want to see our students go from emerging in a skill to developing that skill, and finally to mastery of that skill in order to be able to progress into more difficult concepts in later grades. The National Council of Teachers of Mathematics, or NCTM, developed a set of mathematical practice standards. The 8 practice standards, which are listed on the slide, are also discussed more in depth in the feature of core modules. These mathematical practice standards are critical to our teaching of mathematics. We encourage you to explore the guidance documents available from NCTM. A quick review of these mathematical practice standards is as follows. First, we need to make sense of problems and persevere in solving them. Remember, this is what we want our students to be able to do. Students must also be able to reason abstractly and quantitatively. Students should be able to construct viable arguments and critique the reasoning of others. Students should be able to model with mathematics, using appropriate tools strategically. They must also be able to attend to precision, look for and make use of structure, and look for and express regularity in repeated reasoning. To determine if students are mastering content, we must assess our students. There are many forms of assessment, but formative assessment, including ongoing continuous progress monitoring, are critical in helping us to identify when an instructional change is needed. Monitoring progress should be related to an academic goal connected to the standard being addressed. So let's take a brief brain break for some reflection. Consider the questions on this slide. What are your current levels of knowledge and implementation related to core Tier 1 instruction in mathematics in your classroom? A couple of things that we would like you to think about as you stop and reflect are, who's doing the talking in your classroom? Is it mainly the teacher? Is it the students? How are you assessing that? Who is doing the math? Again, is the teacher the only person modeling mathematics, or are students actually modeling various techniques in mathematics? Go ahead and reflect, pause the video if you need to. In order to improve mathematics learning for all, effective Tier 1 instruction of rigorous content is required. The term listed on this slide, high leverage practices, or HLPs, refers to effective instructional practices that educators can leverage across any content area to increase the likelihood that students achieve. HLPs fall under various domains. The area of focus throughout this presentation will be on the HLP, or high leverage practice, related to instruction. We'll focus specifically on adapting curricular tasks and materials for specific learning goals, providing scaffolding supports, using explicit instruction, and using strategies to promote active student engagement. Differentiated instruction is one way that we can adapt curricular tasks and materials for specific learning goals. This is one of the high leverage practices. One of the things that differentiated instruction helps us do is maximize growth and individual success. What we are able to do then is customize to the way individual students learn and adjust our content, our process, and product in response to students' readiness, interests, and their learning profile. It's important to remember that all students learn differently, and so differentiated instruction allows us to be able to provide instruction that meets that individual student's needs. The other key features are really thinking about students and teachers being collaborators in this model and flexibility as being the hallmark. There are a few different stages within differentiated instruction. What we'll talk about now is really a focus on employing effective classroom management procedures, various methods for grouping students for instruction, methods for assessing readiness so that we know exactly where to start or begin our instruction, and teaching to a student's zone of proximal development. A few of the strategies for each of the stages that we just talked about are listed. Under effective classroom management procedures, things like learning contracts or choice boards may support. For some of our students who struggle in mathematics, they may actually try to escape or avoid tasks that are difficult for them in mathematics. And one of the effective classroom management procedures that we can put in place would be a choice board, so that they can choose, do they want to work on the task independently? Do they want to work on the task with a peer? Do they want to take a break first? Or do they want to start maybe answering 5 questions and then take a break? So choice boards help us change the setting or the antecedent to really allow the student to be able to take ownership over their own learning. In addition, we can select various grouping strategies as part of differentiated instruction. We might be able to group our centers by interest areas, or if we're using specific small group instruction within our core instructional practice, we may focus those on various interest areas as well, grouping students with similar interests together. In addition, there's multiple ways that we can use grouping flexibly. For assessing readiness, we would look at assessments for grouping. So how are we identifying students to group them either in a homogeneous way, so grouping students with similar need areas or similar strengths or similar, again, interest areas of learning, as well as compacting. And in the area of teaching to students' zone of proximal development, we can provide some anchoring strategies and opportunities for independent instruction, as well as cubing extension menus. If you're not familiar with some of the terms that are listed here, we encourage you to look into the work of Tomlinson, 2003, and also explore some of the additional resources and content modules that you can look into available from other sites and other places in the resources section of this module. Let's now take a look at a hypothetical example in a classroom with Mrs. Kim as the teacher. In a lesson designed to teach multi-digit subtraction, Mrs. Kim outlines her 5-step process. That's the start with a task analysis, 5-step process, so that she can more accurately determine where in the process a student may need differentiated support. Is it at the expanded notation part? Is it the addition of differences part? In this hypothetical setting, Mrs. Kim reviews student data that reveals her students understand place value and have decomposed numbers before. Therefore, she starts her process taking advantage of those strengths. She first expands the minuend and subtrahend per each place value. This decomposition shows the place value and sign of each digit. Since the students haven't learned how to subtract to equal a negative number yet, students must regroup to make each place value subtraction equate to a positive familiar number. Then subtraction is performed vertically per place value. Each difference is connected to the total the number of hundreds, tens, and ones, and finally the accurate final answer is displayed. In the class, Mrs. Kim has been able to identify a group of students who have experienced more difficulty. The students' deficits are as follows. 2 students lack place value understanding, 1 student forgets to regroup, 2 students are weak at single-digit subtraction, and 2 students misalign or lose track of their subtraction per place value. You can see that these concerns or areas of need for each student were able to be more easily targeted and identified through the task analysis or that 5-step process that we outlined on the previous slide. So using a student needs chart, which Mary Little and Brad Witzel put together, Mrs. Kim aligns the student deficits with the concepts within the lesson. So you can see that listed on the slide in front of you. Let's look at how the student deficits affect their work through each step within the multi-digit subtraction. So at the expanded notation, 2 students are not strategic in determining the place value. Those are the missing skills for that particular student. At the regrouping stage, 1 student forgets to regroup and subtracts to a negative number inaccurately, listing that 2 minus 4 equals 2. At the single-digit subtraction stage, 1 student is inconsistent and 1 student is inaccurate. And at the vertical alignment of subtraction stage, 2 students misalign numbers in vertical computation. Differentiation is then set for each student's deficit so that every student can access the standard. The differentiation is then coded to show which are student-dependent and which are highly teacher-dependent. So you can see the red on the chart are dependent, black on the chart is the transitional, and the green are independent, but there's prior cueing put into place. So the strategies for differentiated instruction or differentiation are listed in the last column. So for that student who's not strategic, or those two students that are not strategic in determining their place value, we would want to scaffold place value before beginning the lesson. For the one student who's forgetting to regroup and subtracting to a negative number inaccurately, we would want to just verbally cue before that step. For the student who is inconsistent and or inaccurate with single-digit subtraction, we might monitor one and provide a calculator to the other. And for that final area of vertical alignment of subtraction, the two students who are misaligning their numbers in vertical computation, we may have them use expanded notation and or graph paper to help them keep those numbers in alignment. Once we've identified the skill areas necessary to solve the problem, those skill areas can then inform a student-level formative assessment recording form. We'll discuss in more depth formative assessment recording as we move forward in this module. When we assess student learning, Mrs. Kim uses her 5-step approach along with the student differentiation that we discussed previously. For students like Angelina, the difficulty is with operations. As such, she receives a faded multiplication grid. Don't worry, we'll talk about that in a little bit. Another student, Petra, is an English learner who struggles with the language of mathematics. For her, the teacher sets up a time to prepare the place value language with her briefly before the activity to activate her memory for such terms as 1 tens, 3 ones. For other students with more intensive needs, there is more teacher involvement. Ned has a learning disability and struggles with manipulating numbers. For Ned, the teacher will cue him as to what needs regrouping. Now let's discuss how we scaffold our instruction as a way to address the areas where students are struggling so that they can master the complete task presented to them. We understand that students often require explicit instruction, but we don't want students to be dependent on us for too long. Rather, we want our students to become more independent. Scaffolding is a temporary or adjustable set of supports designed to help students master content and perform more independently, such as on standardized or summative assessments. There are several types of scaffolds that exist. There's content scaffolding, which is selecting the content that's right at the level for the student using familiar and interesting content. We try to build it starting with easy things that the students are familiar with and building up slowly, bit by bit, to a more complex idea. There's also task scaffolding, which means modeling and stepwise instructions where you're trying to fade the teacher guidance on that task. Mnemonics are a great way to get started, and obviously a teacher think aloud that is owned by the students later on when they are solving problems. Finally, there is material scaffolding, which can be cues, prompts, examples, or simply the material objects that you're using. If you are using a concrete object consistently across mathematical content, it helps students see how a process grows in mathematics through the progressions. So let's go through an example of scaffolding. We discussed earlier a student named Angelina who struggled with computation. When teaching complex computation, how many of us have said, I wish these students knew their basic math facts? So what do? Well, oftentimes we might hand over a calculator. A concern with using calculators is that students can access every multiplication problem, including those problems that they've already learned or mastered. A concern is that students look up every calculation, even the ones that they've mastered. This lack of confidence may interfere with competence and definitely will slow down the problem-solving process. As such, we encourage a scaffolded multiplication grid. So the use of this multiplication grid is to work with a fluency, or to work on fluency. It is important to fade the utility of this grid so that the student relies more on what they already know. Likewise, we should make it difficult for students to look up answers which they have already memorized or mastered. This slide shows an example of a multiplication grid which reveals all of the multiplication answers from 1 to 10. So the student could look up 9 multiplied by 8, match it up, and then say the answer is 72. The first step when using a multiplication grid is that all the math facts are included. When we provide such an accommodation with complex content, such as long division, students repeatedly look up every answer in this grid to find every answer within the step-by-step process. So even though we are teaching long division, we are still working to help the student build fluency of math facts in order to release some of the cognitive load of looking up at every fact later on in their future work. Some of the first facts we teach our students are the multiplication of ones and tens. Once those facts are mastered, we remove them from the multiplication grid so that the student isn't tempted to just look at the grid to locate an answer to a multiplication problem like 2 times 10 that they have already mastered. The student will already know that the answer is 20 without needing the visual cue on the grid. Hopefully you're recognizing that this slide shows that the ones and tens columns and rows have been removed. In the example here, we are assuming that the student has already mastered ones, tens, and fives. So to further scaffold this multiplication grid, we will also delete the 5 facts so that the student gains independence with the multiplication of fives. As the student learns multiplication facts, learning may become more spotty from fact to fact. Using this chart, the student should no longer be able to look up facts that they have already mastered. So a student wants to look up 8 times 8, but they've already mastered it. They look at the chart and see that it's blank there. That makes them think, I've probably learned this before. And then they remember a mnemonic they learned. Wait, he ate and he ate until he was sick on the floor. 8 times 8 is 64. Right. In this case, a potential crutch for learned helplessness is gone by just putting the answer in that spot. So we are pushing the student to not only learn individual facts, but also recall them later on. As the student gains independence, this chart becomes more and more bare until the student is completely independent in each of the areas on the grid. Our goal is to show how we support a student's independence in mathematics through this scaffolded approach. We're now going to reflect on a fictional student, Jackson. We'll be looking for ways to answer the question, in Tier 1, at the core level, how can we differentiate for students with mathematics weaknesses? So here's the background behind Jackson. He is a 5th grade student who has experienced persistent failure in mathematics. Error pattern analyses point to difficulties in whole number multiplication and division, especially multi-digit, computation of fractions and decimals, proportional reasoning, and word problem solving. Some behavioral difficulties that have emerged in our data show that he evidences escape behaviors when confronted with difficult tasks. He will engage in such behaviors as getting out of a seat, refusing to do work, and initiating off-task conversations of things he finds more interesting than mathematics. I mean, come on, Jackson, isn't math the most important thing going on? I guess not for him. So as you go through this case study, here's one question we pose. What general strategies would be helpful for Jackson and other students demonstrating similar learning needs? Think about the concepts we want to get across, that word problem solving approach we are worried about, and then what we are going to do with the multiplication and division. Go ahead and pause the video and think of some strategies that you might use for concepts, word problem solving, and multiplication and division. Here is what we are thinking. To improve his conceptual understanding, how about using linear models? This might be really helpful for magnitude understanding. How about the concrete, representational, abstract, or CRA model, or concrete visual abstract, some people call it, approach? This graduated sequence of instruction could help a whole and rational number computation, helping Jackson and other students move from using manipulatives to developing abstract understanding and completing algorithms. How about word problems? What did you come up with? We came up with teaching a student to use self-regulation so they can analyze his problem solving as an important strategy. Also, schema-based problem-solving approaches are excellent for approaching word problems, and we would recommend this for a student such as Jackson. For multiplication and division, if we are teaching complex concepts, we could limit the facts to the facts that Jackson already knows. We could also use the faded multiplication grid to help scaffold Jackson's success. So what ideas did you come up with? Did you conclude with similar ideas or come up with even better ideas? For our next question, how could you differentiate instruction for a small group of students to access and master the standard? For this case study, the 5th grade standard was for Jackson to write and interpret numerical expressions such as 14 minus 9 divided by 3. What should Jackson do to demonstrate this content? Also, what are some of the prerequisite skills to meeting that standard? Go ahead and pause the video and think about the prerequisite skills needed for Jackson to solve this problem. What we recorded were place value, order of operations, and simplifying expressions. The work of Ortiz 2015 can help us identify a lot of these prerequisite skills that lead to the standard. Did you come up with other prerequisite skills to this 5th grade standard? Remember the recording chart that we introduced earlier. What are the steps you would be recording on your chart? For a student like Jackson, what are some of the supports you would put in there to support him based on his deficits? On this slide and in this chart, you will see that to support Jackson with order of operations, we will provide the anchor chart. And for multiplication and division, we can use the multiplication grid, keeping in mind what we discussed earlier about scaffolding the grid as Jackson masters facts. To summarize what we've covered in this module, effective instruction starts with a strong foundation. At Tier 1 of a multi-tiered system of supports, it is important to set purposeful and thoughtful differentiation and scaffolds to support the learning of all students, including those who are struggling within core instruction. If when looking at your screening data, students with disabilities, English learners, or other subpopulations of students are not achieving at the same rate as their peers during core instruction, we need to consider the use of our high leverage practices of differentiated instruction and scaffolding to support their understanding. All students can learn if we set them up for success. We'd like to take a minute and acknowledge the great team we have in place. The faces toward the right may be more familiar to those of you working in our partnering schools. The two on the left, Dr. Mary Little and Dr. Brad Witzel, helped develop the content for this module. We can't thank them enough. And if you haven't checked out their book, Teaching Elementary Mathematics to Struggling Learners, we encourage you to do so. We also encourage you to check out the resources section for additional resources, tools, and places that you can go to explore some of the content that maybe is still unfamiliar or you would like a deeper dive with. And that's going to be found in the resources section of this module. Thanks so much for watching, and we will see you next time. Bye.